next section focuses on graphs for qualitative data. So the first thing we're going to look at is a data set where we've been told the number of cavities that people have had and the frequency that it occurred. In this case, we looked at 100 students. Those 100 students told us how many cavities they've had, and we wrote down how many said each thing. 19 students said they had 0 cavities, 26 students said they had 1 cavity, 11 said they had 2, 8 said they had 3, 6 said they had 4, and 30 students said they had 5 or more cavities. First thing we're asked to do is to construct a bar chart for this data. In order to construct that bar chart, I'm going to start by making 2 axes. Along the vertical axes, I'm going to look at what the different variables, frequency numbers are. So in this case, it looks like the lowest I see is 6, the highest I see is 30. I'm going to decide to go by tens. So I'm going to start 10, 20, 30. Whenever I do this vertical axis, I want a label on it, so this is going to be frequency. Down here, this is going to be number of cavities. And I'm going to create a bar for 0, a bar for 1, 2, 3, 4, and 5 plus. As I make these bars, I just want to make sure they make relative sense. I would say that for both this and the next section, we're going to talk about how you would make these graphs by hand, but really you would want to make these by computer. Excel would do a much better job than we're going to do on them by hand. We are going to do a project in Excel that's going to let us see how everything would run through a computer. But initially, we're just going to see how you would draw these if you didn't have a computer available. So 0 cavities happen 19 times. I'm going to draw a bar that stops just short of 20. Notice that the bar doesn't touch the original axis and it doesn't touch the next bar. 26 is higher than that, short of 30. 11 is a little past 10. 8 is a little lower than 10. And 6 is a little lower than that. 5 plus goes all the way up to 30. So the things I really care about when I'm drawing a bar graph, make sure I have proper labels on both axes, make sure these aren't touching like a histogram would, make sure I have a reasonable scale here. When I go to construct the pie chart, it's a little trickier. Again, this is a time where I'm not going to get out a ruler to make it look exactly right, or a protractor in this case. I'm just going to try and eyeball it. But you would really want to use a computer to do this if you were trying to do a nice presentation here. That said, in order to construct a pie chart, the first thing I have to know is what the angle should be. So in order to do that, what I would normally do is I would take this frequency, I would divide it by the total number of respondents to get a decimal, and then multiply that by 360 degrees, the degrees in the circle. In this case, the data is nice because it came from 100 students, so I can right away say that these frequencies, if I put the decimal point in front of them, represent what the proportion would be. So really, 19 divided by 100 would give me 0.19, which is the proportion that had 0 cavities. If I took that 0.19 times 360, that would tell me 68.4. So all I'm doing is taking this as a decimal, multiplying it by 360, and getting what the central angle would be that I want to draw. If I continue with this, 0.26 times 360 gives me 93.6. 0.11 times 360 gives me 39.6. 0.08 times 360. And remember, when you're doing this with a single digit frequency, or when you have a division problem, you get that 0 in front. That 0 is important. So 0.8 would be 80%. This is 0.08 or 8%. That gets me to a 28.8 degree angle. 0.06 times 360 gets me to 21.6. And 0.3 times 360 gets me to 108. So I now have all of these different degrees. I want to construct a pie chart. I'm going to try and use some different colors here. So what I'm going to start out doing is just making my circle. Then I'm going to look for the biggest piece of the pie. What I see here is 108 is the biggest piece of the pie. I'm going to say that's like a right angle that would be 90 degrees, and then just a little more. I'm going to label that as 5 plus, and I'm going to put the percentage in there, 0.30 or 30%. Next one I'm going to do is the next largest, which is 93.6 degrees. That's almost a right angle, just a little bit more. That represents having exactly one cavity, which was 26% of the people who responded. The next one we're going to do is the next largest, which is 0 cavities, 68.4%. So I would say if this is a little less than 180, I'm about a third of that. Maybe I go like there. So I'm going to call this 0 cavities and label it 19%. I need to break up what remains into 11, 0.08, and 0.06. So I'm going to split this into 3 parts and see which one's the largest and then which one's the smallest. So these look about equal, which wasn't ideal. Maybe like that would make them look a little less equal. So let's say that that biggest piece in the middle is going to be this 11% or 2 cavities. So 2, 11%. We'll call this one slightly larger than that one. So this one's going to be based on 3 cavities, which is 8%. And then this one's going to be based on 4 cavities, which is 6%. Again, I would never do one of these by hand when I had a computer available. We're really just talking about the idea of how you create a pie chart. That said, I do want you to know the process, that in order to find the percentages, you take the frequency divided by the total number of people in the sample. Once you have that division done, multiply by 100 to get back to the percentage. If I have that division done and I multiply by 360, that tells me the central angle. Really, if I got out a protractor, I can measure these exact angles and make everything perfect. Again, please don't waste your time in doing that. In the end, this should be what my pie chart looks like. I probably want to include a label like cavities in college students. If I wanted, I could just make each pie piece, each section, a different color, and then provide a key here telling what each of the colors were. I tried to kind of write in as I went, but really that key might be more helpful. Now that we've created a bar graph and a pie chart, we're going to answer a couple questions about bar graphs and pie charts. This bar graph here tells us favorite seasons from people that were asked. It asked me what the most popular season is, so I look at the highest bar. There's the highest bar. That's why I'm going to write as the most popular season, summer. Order for a Pareto diagram. So your book doesn't go huge into Pareto diagrams, but I still like to include them. Basically, all a Pareto diagram is a bar graph written in either ascending or descending order. When I say that, what I mean is they put the bars largest to smallest or smallest to largest. In this case, I'm going to list the order for the Pareto as largest to smallest. So largest is summer, then spring, then fall, then winter. So really I would rearrange, put this bar first, this bar would stay second, this bar would move to third, and this bar would move to fourth. It's not particularly helpful here when it's pretty easy to make comparisons when there's only 4 bars. The example I like to give where Pareto is particularly helpful is if, let's say, you listed every defense budget of every country alphabetically, you just have a bunch of low bars, huge one for US, huge for China, huge for Russia, so on, but you couldn't really compare things that are alike. If instead you listed it by defense budget and went largest to smallest, it'd be much easier to see where countries fall in relation to each other. So really when you have a large number of bars is when it can be useful to use a Pareto diagram. At the bottom, last thing we're doing is breaking down this pie chart. People were asked which their favorite color was, red, white, or blue. The color that was the least popular is white, that only got 25%. If I was trying to figure out what central angle is used for red, I would want to take this percentage, convert to a decimal, 0.35, multiply it by the number of degrees in a circle, 360. If I put that in my calculator, 0.35 times 360, that's how I get to 126, which is the central angle for red.